Le Chatelier's Principle, Pressure, Higher Content by KayScience.com. Le Chatelier's principle states that if a change in conditions is introduced to a dynamic equilibrium, the position of the equilibrium will move to cancel out the change. Change in conditions includes concentration, pressure, and temperature. In this video, we're going to focus on how changing the pressure affects the position of the equilibrium. It's question time. Attempt these questions to check your understanding. So, pressure only affects gases in chemical reactions. For example, in this chemical reaction, NO2 is a brown gas and N2O4 is a pale yellow gas. So this sealed container contains the brown NO2 gas and the pale yellow N2O4 gas. And currently the reaction is at equilibrium. And if the size of the container is reduced so that the reacting particles are now at a higher pressure, then Le Chatelier's principle states the position of the equilibrium will move as the pressure is increased. Whereas, if the size of the container is increased and there is now a lower pressure, again, Le Chatelier's principle states the position of the equilibrium will move as the pressure is decreased. It's question time. Attempt these questions to check your understanding. This symbol equation shows how there are two molecules of NO2 reacting in the forward direction to form one molecule of N2O4, and in the backward direction, one molecule of N2O4 is reacting to form two molecules of NO2. So there are two molecules of NO2 on the left and one molecule of N2O4 on the right. If the pressure increases, the position of the equilibrium moves to the side with fewer molecules. The equation tells us there are two molecules on the left and one molecule on the right. So there are fewer molecules on the right. This means the equilibrium moves to the right. More N2O4 is formed to counteract the change in pressure. The effect on the color of the reacting mixture is that it goes from being more brown to being more pale yellow. This is because more pale yellow N2O4 has been formed. It's question time. Attempt these questions to check your understanding. Now, if the pressure decreases, the position of the equilibrium moves to the side with more molecules. Therefore, the equilibrium moves to the left as there are two molecules on the left and one molecule on the right. So more NO2 is formed to counteract the change, which was the decrease in pressure. As more of the brown NO2 is formed, this causes the reacting mixture to become more brown. These are the observations when the pressure is decreased. It's question time. Attempt these questions to check your understanding. In this chemical reaction, we can see iodine and hydrogen react in a reversible reaction to form hydrogen iodide. The balance symbol equation tells us there is one molecule of iodine reacting with one molecule of hydrogen. Therefore, there are two molecules in total on the left. And the balance symbol equation also tells us there are two molecules of hydrogen iodide being formed. So on the right, there are two molecules in total. So because there are an equal number of molecules on both sides, changing the pressure has no effect on the position of the equilibrium. But Increasing the pressure equally increases the speed of both the forward and backward reactions. It's question time. Attempt these questions to check your understanding. Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets, and quizzes at KayScience.com. And don't forget to like and subscribe.